Hello students, welcome in chapter 7, integrations. Students, today we are going ahead our exercise 7.2, 32 questions. Integration 1 upon 1 plus cot x dx. Yes students, that time numerical already I given you in the homework in the last two parts. Yes students, here cot x I just resolved in the parts of cos and sin. So my first is cot is write down cos below sin, take LCM. So sin x by sin plus cos x, and this is a turning point now. For turning point, 2 divided and 2 multiplied. Necessary. Other number is not valid. Only 2 is valid. Because denominator value, same I create the numerator. So here write down sin plus cos, that is my denominator value. Correct? This and this cancel, but I want to do sin, so we write down here sin minus cos. Check. This cos and this cos, if you cancel, you get sin to sin. Now this divided and that divided. So your answers is your half 1 and plus sin minus cos upon sin plus cos. And you can create both of these students separations. So this half I multiply here, this half with this one and half with this one. So half with 1 dx and half with the sin minus cos, sin plus cos. Now students, this answer is done. It is x. And this is remaining. After that I start these remaining parts according to suggestion method. Here suggestion T denominator, you can create numerator. So suppose sin plus cos, always you try to suggestion depend your denominator and differentiation with respect to x. So students, sin derivative cos x, cos is minus sin x, and I want to check here numerator, sin minus cos, it's coming, yes, minus outside. So what is the sin minus cos? Dx minus dt, and this value actually minus I common taking, and sin minus cos x dx is this. So here integration 1 done, so I return here c1. One integration finished. So I is equal to students x by 2 half, it is minus dt upon t. Now 1 upon t integrations, is that also known? It is 1 by 2 minus outside, half outside. dt by dt is a log of modulus 2 c1 plus c2. And this c1 plus c2, we can write down new arbitrary constant c. And t also put it. So my final answer x by 2 half log t is your sin plus cos, and c1 plus c2 is finally c. And here students, your question is happily done. Same question, if I ask you here 1 minus cot x, you try itself. And now after I going to 30. Now students, continue question number 33. Also IAP questions. Same related your 32. 10 translate in cosine, sin cos. So I again write down here 10 is sin by cos x is a power. So you can get cos x dx, and that will be cos minus sin x. Again, try to balancing two necessary, yeah? Upper and lower. So here 2 multiplying 2 divided. Because I want to balancing according to denominator in numerator. So your denominator value is a cos minus sine. So the same I write down here, cos minus sine. But now wait, you want to do cos x. One cos x written already. So I write down another cos, but here sin x. Check sin and sin cutting, this sin and this sin. Cos and cos, 2 cos x. Now these are divide with these are division, separations. So students, I is the integrations, one of the one, but other of the cos plus sine upon cos minus sine dx. And now students, I start both separation, this upon this one and this upon these are remaining. So students, my solution is I with the half of 1 dx with the half of another cos plus sine upon cos minus sine. And now try to, this integration is x. So my answer is half with x plus the same is. Students, it is a repeat question. Third time we will start the same sum here plus c1. Yes, integration 1 plus 10x. Already I explained you in the example number I think 5 or 6. Correct? Now this assumption. Suppose cos x minus sin x is t. Very easy. Derivative differentiation with respect to x, it is minus sin x, but that is minus cos x dt by dx. But now here wait students, I want to cos plus sine. Take minus common outside. So what is the cos plus sine? Dx. Yes, it is minus dt, and this full value apply here in the place of this. So my integration I x by 2 half minus dt by t. That integration known I. So my answer is x by 2 minus half log modulus t. C1 and C2 you can create a new constant arbitrary, it is C. So I'm t putting, what's your t? T is your final suggestions cos minus sine, and here students C, and here numerical term, but you can write down where C1 plus C2 is equal to C is arbitrary constant, and that's your students final answer. To rearrange it here, 1 minus 10x. You also write down same practice numerical 1 upon 1 plus 10x, and this whole numerical I am the numerical. Now continue students, question number 34, which is very most IMP in exam level. Under root 10x by sin x cos x dx. Students, root functions related I assumption t, it's best way. So my first starting steps, suppose root 10x is t. So what you get 10x? T square. Now start derivative, differentiation with respect to x. So tan derivative is a sec square x. Here 2t and dt by dx. So you can get students sec square x dx, which is 2t dt. And now you wait. This value actually sec square x is present. Yes, this down in this form, then it is x square x coming. Sine below cos and here cos square. Check. One cos and one cos cancel. Then quotient balance. And this what? 1 by cos square x is a sec square x. This what? Tan x. In shortly, I just write down here this full function in the terms of t. This your sec square x dx. That is your own t square and this is a t finished sum. But this is the main thinking here, students. So my answer is integrations. Root tan x is t, tan x is a t square and sec square x dx is a 2t dt. Now integration I 2t square by t square gone. Only you have to do 1 dt, which is t, and happily done. T value is a tan x plus c. So does this numerical done? But here I give you one of the extra sum. This is also good question. You will try at home. It is IMP root cot x cos with sine. Definitely same process apply. Root cot x t. Your answer is become -2 in the root cot x. That's your answer coming up if you operate by this method. But this is a very most IMP. Gujket level already board asking this question, either these questions. So you try itself this one. Yes. Now 35. 35 is a log function given. So just I think about that. Dx by x is a derivative of log x. So students, I start. Suppose 1 plus log x is a t. Don't write down whole square also. Only 1 plus log x. So differentiation with respect to x. Now derivative is 0. Here 1 by x and then dt by dx. So what is the 1 upon x dx, students? Dt. And this 1 upon x dx indirectly you coming the dt forms, and the total value I just operate here dx by x, and that one dt. So my value is 1 plus log x whole square is t square, and that is dt. Finished. Only integrations. So integration is what? T cube by 3 plus c, and happily putting your t value. What's my t value? 1 plus log x basic the cube by plus c. And here students, your final funda for log x the whole square is to cube by 3, and this 35 questions also easy and over here. But students, one more time repeat, 34 is the most current questions for exam. Now I go into next one. Now students, question number 36. This is also one kind of typical questions. X plus 1, x plus log x whole square by x dx. Students, first of all, I just think about what is the derivative of x plus log x. 1 plus 1 by x. That's why this and that I take both of the combine. So my integration is x plus 1 by x and other same. Actually, this place suggests t. I create one this. It is the 1 plus 1 x, and this same is. So just I write down x plus log x the whole square with the 1 plus 1 upon x dx. Students, finally I did that here suggestion t. Suppose, that's why this I thinking about that x plus log x base is t, and take derivative differentiation with respect to x. So 1 plus 1 upon x, here dt by dx. So So your data is 1 plus 1 upon x dx dt. And this data actually already I prepared according to thinking, and these are division. So students, my data is a t square and that is a dt. Finished. So what's your answer? T cube by 3. And putting the t successfully. What is the t? X plus log x base is the cube plus c. And here students, happily this question done. But this not easy. You first think about that internal parts directly, and that raised to square. After that I put it here. And this is addition. Directly is 1 plus 1 by x. Actually, it's coming from here. These are division, x plus 1 by x. Now next one, 37. This also most IMT numericals. Inverse function given. Students, always you can try suggestion for inverse functions. Tan inverse x raised to 4 is also given in the parts of composite function. It is parts of composite functions. Suggestion T, derivative, easily. So suppose, students, tan inverse x raised to 4 is a t. And you can make derivative respect to x. So differentiation with respect to x. What is tan inverse derivative? 1 by 1 plus x squared. Here 4x cube and here dt by dx. Students, your target is achievement over x cube with the 1 plus x raised to 8 with the dx. All coming here. Only 4 is extra. So x cube dx 1 plus x raised to 8 dt by 4, and this full value x cube by 1 plus x raised to 8 dx is dt by 4, and this function is that one. Don't worry, I again write after the rearrangement. So sin tan inverse x raised to 4, and that will be x cube by 1 plus x raised to 8 dx. This I just talking about that, this one. And that is the t with the sign. So my answer is sin, it is t. And that will be dt by 4. Now happily done, sin t integrations. So my answer is minus 1 by 4 cos t. And students, just I put it value of t. What is the t? Yes, cos with the tan inverse with the x raised to 4 plus c. So cos t is a tan inverse x raised to 4. And here students, my final answer 37 numerical time. Now students, slowly going ahead. Question number 38 and 39. Both of the MCQ type given questions. Here also I think about to anyhow remove the denominator value x raised to 10 and 10 raised to x. So best way, denominator related suggestion t. So students, here this place I just assume x raised to 10 plus 10 raised to x is equal to t, and start derivative differentiation with respect to x. So 10 x raised to 9 plus 10 raised to x log 10 basic, and this time dt by dx. So 10 x raised to 9 10 raised to x log 10 basic with the dx is dt. Students, this part actually represent your question. Check. Full validity. So my question is 10 x raised to 9 plus 10 raised to x log 10 basic upon x raised to 10 plus 10 raised to x dx. This full part is your dt, students, and upon the value is t. Now finished, which is log modulus t. And putting the value of t. What is t? And value put it. So my t value is, students, x raised to 10 plus 10 raised to x plus c. And here, students, this data is happily done. After that, you tick mark your options. Students, here 39, which is again very most IMP questions. Many times asking in this exam. Dx by sin square x cos square x. You also think about anyhow remove the denominator. So we can write down 1 dx upon. Why write 1? Because this one is actually identity regarding to sin square x plus cos square x. And here same as sin square x into cos square x dx. Actually, these are the identity. And why I write down? Because these are division and other are this division. Both separation. So my first answer is 1 by cos square, other 1 by sin square with the dx. Students, check here. Your denominator remove, product form also remove. I go into addition form, and that is only sin square x and cos square x. And after that, you can create your data sin square x dx plus cos square x dx. And both integration I know here. So my answer is finally that 10x, it is cot x plus minus cot x. And this is the IMP question, students. Here 39, here 10x, and it is minus cot x. Derivative of cot x minus cos square x. And here 39 is happily done. And students, this exercise also finished here. Now I start examples. Now students, after exercise, I am going ahead. Exercise after that, example 7. Cos square x. There are 3 numericals. Very easy first two, but third is difficult. So first of all, cos square x. Students, cos square formula you know that? Yes, 1 plus cos 2x by 2. Yes, that is the rule. Our fifth group. If you know 11th science trigonometric formula, cos square x, sin square x is also known, 1 minus cos 2x by 2. Here 1 plus cos 2x by 2. So I just separate half 1 dx and half cos 2x dx. And here time coming to answer 1 integration x. Here students, just I wait. What is the coefficient? 2. Coefficient divided. So my answer is 1 by 2. Here sin 2x. So final answer x by 2. 1 by 4 sin 2x plus c. And that's the last. An easy answer. Now next one. Second. Sin 2x cos 3x. Angle not same. So I just apply 2 multiply and 2 divided. Higher angle first write down. Cos 3x sin 2x dx. Because I reading 2cs. You know that 2cs? Yes, sin minus sin. So my answer is for sin minus sin. Angle not divided by 2. You know that. Only adding the angle. And here subtract the angle. So my answer is half sin 5x. Here sin x. And now you create easily answer. Students, here again I told, anyhow multiply remove converting into addition either subtractions. Division form, multiplying form, anyhow you try to remove that. So my answer is half sin 5x dx. Again half sin x dx and create the last answer. So sin integration is a cos, but the coefficient must be divided. Here also sin cos but minus. Students, here minus right now, already I written here. So my answer is minus 1 by chain cos 5x, and that is half plus C, and that the student's last and final answer. Very easy. But anyhow, you try to product form, either division form, in the form of, yes, in the form of addition, either subtractions. Now continue. Next one, sin cube x. Students, this sin cube x is a very most ideal numerical, because this numerical have different types of answers, and both I explain one by one. First of all, I operate this formula, sin 3 theta, 3 sin theta minus 4 sin cube theta, you know that, correct? And cos theta also come, 4 cos cube minus 3 cos. Students, here this cube, I just make the separations. So 4 sin cube, which is 3 sin minus sin 3 theta. So what is the sin cube theta? Which is 3 sin theta minus sin 3 theta upon 4. And this value actually utilized in the place of here. Then we will go to answers. So my integration sin cube x dx. This is exactly 3 sin x minus sin 3x by 4. And try to separations. Students, here subtraction easily going in answer form. So 3 by 4 integrate sin x dx, and 1 by 4 integrate sin 3x dx, and now operate the answer. So students, this answer is what? Sin integration minus cos x. Here also minus cos 3x, but coefficient divided, plus c. So this answer is done. Minus 3 by 4 cos x plus 4 3 is 12 cos 3x and plus c. Yes students, this answer is happily here done. But same questions I again explain you by the different method. Now students, same question I go to different levels and deeply going again by the different method, and answer is also different students. So question is same as in alternate method. In other ways, sin cube x dx, definitely we will write down here sin square x into sin. Which derivative of sin? Cos x. So suppose I just assume cos x t, differentiation with respect to x. So students, here minus sin x dx, which is dt. So what is sin x dx? Minus dt. And this sin is actually operated. And the sin square, students, I just write down 1 minus cos square x. Another same is, so my data is 1 minus t square. This is 1 minus t square because cos x is t, and sin x dx, that one, it is minus dt. So students, my answer is a minus 1 into 1 minus 1 plus t square dt, minus multiplication. So answer is students minus t cube by 3, and t put in. What's the t? Cos x. So minus cos x. Here cos cube x by 3 plus c. And here students, question number 3rd, either this true, either this true. Both of the true, anyone you write in exam. But if you MCQ type, then MCQ type A B asking. Here also constant A B asking. Yes students. Here this example 7 done. And this part is also students, I stop here. Further explanation same, I explain in the next part. Okay students, bye bye.